Hi, let's begin with a couple of announcements. First of all, this lecture is lecture 15 for Engineering 111. It's intended for the 28th of February 2017. Now, as a reminder, we're going to have video recordings for both of the lectures this week, and so we won't have any class on Tuesday or on Thursday. So, important announcement. As we work through today's lecture, please be sure to follow along with the examples that I'm doing. You need to pause the recording and actually do the same functions that I'm doing, and I show you during the lecture how to create a new worksheet and on different pages have different parts of the examples. So upload those examples online in order to get the participation and attendance credit for this lecture. The other important announcement is related to homework 5. That assignment is due at 11 o'clock on Tuesday, March 7th. So you need to upload that to MU Online in the same way that we have been in recent other assignments. Just upload that and then let me know if you have any questions. Now today we're going to be covering some of the more powerful functions that Excel has available, getting into some more sophisticated territory such as converting between units, using a sophisticated lookup tool that can automate the assignment of values into categories, formatting with dates and times, and then even some logical statements, if-then, using the if function. So it's a really great lecture with lots of important information, so I hope that you will follow along carefully and be sure to pause the recording and so that you can create the same example file as is shown on the screen. Okay, now the built-in functions are meant to perform some sort of a process in an automatic way. And this is just a diagram that kind of illustrates that you have an input number, the function does that process, and it comes out with the output or y value. So it's some function using the input. So take, for example, if you want to know the sign of the value x, or maybe another function would be to if you wanted to find the angle based on coordinates, or a logarithm, natural log or base 10 log. So those are just some examples of functions that probably a lot of people are already acquainted with, and in fact Excel can do all of those functions. So in order to use the function in Excel, one thing that you have to know is that it exists, and even if you don't know its name, you can sometimes, if you know part of its name, you can find the one that you're looking for. That's the beginning point. Excel, fortunately, will prompt you to know what the format is for what you're typing in. It kind of gives you hints along the way, and I'll show you what I mean by that in just a moment. In addition to the hints of what it needs to know for the function, it also even gives you the hints on what the order is for the input parameter. And then the output of the function is only of use to you if you know what it is, like the type and value of the output. So here's a look at in Excel where you can access the pre-existing functions that it already has here in the function button. Once you click on that, then it will give you different categories of functions that you can either search for or you can look at them up based on the category that the function is in. There are functions related to financial calculations, conversion between dates and times, just some simple math and trigonometry functions, those that are related to statistics, and even functions that allow you to prepare tables and look up values from those tables. So let's try some of those out. Less commonly used functions, at least in the courses that you'll be doing in the near future, are the functions that are related to databases and text. Logical statements can be pretty useful, if-then functions, and we will have an example that illustrates that. And there are also units conversions functions that are pretty helpful in engineering courses. Now here's a really lengthy list that extends over several pages, and these are only the functions that relate to mathematics and trigonometry. And there's an even more lengthy list for some of the other categories. So as you can see here, just about anything that you could think of to have Excel do, it can do. Now some of the ones that we use most often are the conversions between degrees and radians, and so the name of the function is degrees. And as with any other formula in Excel, you need to start by using the equal sign if you're going to type the function in manually. Other ones that are pretty commonly used are logarithm and natural log. The function exp is used when you're taking e to some power, and so I think most people have used the e to the power of function before, and you'll use that a lot in environmental engineering. So one that's on this list that's pretty important is that if you don't want to type in pi to all of its digits, you can just use the function pi, and then it knows the value of pi to far more digits than you'd ever need to know it for. So it's a lengthy list is the point. And you can use the help button. If you press F1 in Excel, it'll bring up a help, and you can search for functions that way as well. If you kind of have an idea of something you want Excel to do, but you're not exactly sure what the name of the function is, it always pays to search the help feature. So let's actually go into Excel and try and use some of these pre-existing functions to do the math operations that are shown on the screen here. So I'm going to make this presentation a little bit smaller and go over here to try out some of these existing Excel functions. Okay, so here's Excel, and starting with a blank workbook, we want to first of all find out how many degrees are there in 3.14 radians. Okay, so I'm going to start by clicking here on Insert Function, and you'll notice that it automatically came up with the equal sign. And that's what tells Excel that we're doing some sort of a formula or function. And if I don't exactly know which function I'm looking for, I can put in a brief description here. So if I wanted to say, well, I want it to tell me degrees, I'll type in degrees and then search, and it says, well, what about this function degrees? And it even gives you a little summary here. It converts radians to degrees, and that's exactly what we want to do. So I'm going to click OK, and then the nice thing is it prompts me for the arguments that have to go into the function here. So it's essentially, you can see here in this window, it said equals degrees, and then there are parentheses here. Inside the parentheses is where I should put the number of radians. And here it's even giving me all of the prompts. So it's saying, what should the angle be? And I know 3.14 is what I want to have. So it converts radians to degrees, and it gives you a preview of what the function is going to be after it's converted. And so all of us kind of know that in a circle it's 360 degrees, and a circle is 2 pi radians. So in this case it's 1 pi radian, so about 180 degrees sounds correct. And it would be exactly 180 degrees if I had typed in pi to more digits. And so that's an illustration of how to use the degrees function. And if I go down here into where it's got the number, then you can see that it says the function degrees and then the number 3.14. So that function, insert function button, can be pretty useful if you're not exactly sure what you're looking for, or you need a lot of prompts on what the value should be as you type them in. But over time, as you begin to learn the functions, you probably will find yourself relying on this insert function button less and less often, because you can just remember it and type it in manually. So if I wanted to know the numeric degrees equivalent of, the numeric equivalent of 2 pi. So equals pi, pi, parentheses open and close, times 2. And so it will then tell me 6.28319, and it would give me even more digits if I let it. So that's the numeric equivalent of pi. The pi function is one that's pretty useful. And inside the middle there, if it's empty, then it just assumes it means 1 pi is the default assumption for Excel. Okay, so this last one, what's the sine of 45 degrees? Now this one we have to be careful about, because check this out, sine of 45. And we all know from our previous experience in trigonometry that the sine of 45 degrees is 0.707, right? Everybody knows that. Well, if we do that, 0.8509. Something's not right. Let's investigate by clicking this insert function thing, and then let's type in sine and go, and it says, okay, for the sine function, returns the sine of an angle. All right, well, that's what we did before. Let's see maybe what we would have missed. The number is the angle in radians for which you want the sine. So the point that I'm making here is that the input into the sine function should be in radians, not in degrees. So we put in 45, but what we need to have is the angle in radians. So if we wanted to know, we would need to have an embedded function actually. So we'd need to have, first of all, equals sine, and then inside of that we'd want to use the radians function. Radians converts degrees to radians, and so on that I'm going to have the degrees 45, and so that's going to tell me how many radians there are, and then once I have the radians it will convert those radians into the sine of the angle. So now we get the 0.707 that we all know and love from trigonometry. All right. Another pretty handy thing that Excel is able to do is to conversions for units. And so let's say that we wanted to convert fractions of inches into both centimeters and millimeters. Well, what we're going to do is actually create a spreadsheet that has this same information. And so let me do that. Opening up Excel here, I'll create a new worksheet. And I'm going to have this part sizes, inch, centimeters, millimeters. Now, by the way, I'm going to save this file, and it's important that you do the same because I'm asking students to upload the files that they've created as they worked through these examples with me so that you can get attendance credit for this lecture. So save the file if you haven't already. It doesn't necessarily matter where you do it. I'll just do it here, maybe on my V drive for Engineering 111. So I'm going to call this one Class 15 examples. All right, so I've saved it there. All right, so the table here. First of all, I want to have 1/32 of an inch, 1/16 of an inch, 1/8 of an inch, 1/4 of an inch, a half, 1 divided by 2, and 1 inch. Okay, I want to highlight this and set it as a fraction, but I need to tell it here how many digits it can actually round it to. And so you see how we've got 32nd. I need to tell it can do up to 2 digits. And so now I'll be able to see all of the fractions there rather than reporting it as numbers. All right, so these are inches. Let's say that I want to convert those into centimeters. So I'm going to use the function for that, the convert function. Now, of course, if you don't know how to use the convert function, then maybe the first time we're doing it, we can use this insert function tool here. So I'm going to convert, okay, search for that, and we're going to do the convert function, and it gives you some pretty good hints here. So convert the number, I'm going to click on the cell here, that number, and I want it to be from units of inches, let's see, to units of centimeters. All right, and then click OK. And so it's converted from 1/32 of an inch to 0.079375 centimeters. And was it right? Well, what we know is there's 2.54 centimeters in an inch. So if we drag that formula down and apply it to the 1 inch, then you'll notice it did the 2.54. Great, worked out good. So we've used it that first time. Now, we don't have to always click on the insert function, of course. Let's try it again. Equals convert. And then as I start typing it in, look how it tells me the closest match to what I'm typing. So that's kind of a nice prompt there that helps you know, for example, what needs to go next. And so it's saying, next I need to know what number it's going to be. So I want this to be my number, and from, and it even gives you the options that you could choose, what units it knows. And so I could click on it, or I could just type it in, you know, inches, and then I want it to be in. We scroll down here to millimeters. I'm going to do millimeters. All right, so it is now going to be 10 times as many. So that convert function is pretty handy. All right, we've already seen that. What about dates and times? The interesting thing about the way that Excel stores dates and times is it refers to time as a number, date.time, where it's whole numbers of days. And the starting point is it's counting how many days there have been since January 1st, 1900. And so then the way that the T section works is it's time as a decimal. So if you divide the number of hours by 24, the number of minutes by, there's 1440 minutes in a day, and there's 86,400 seconds in a day. These are all fractions of a day. So time is being expressed as a decimal here. So let's see, 68, 90.47, and so on. Let's see if we can. This is what the slide is saying that date is interpreted as. Let's see if Excel agrees with what it's saying that is the time interpreted is. So I'm just going to copy that number, and I'm going to paste it in here to a new sheet. This is now going to be my time and date that I'm doing here. So I'm just pasting in a number. It's pretty big there. All right. Okay. So it's a number. It's seeing it formatted as a number. But if I go here, I could change it to be a date. And so now it's saying November 11th, 1918. And I could change, there's more specific number formats as well for dates and times. For example, if I wanted to know, if I wanted to express that as what day of the week it was. Now it's going to tell me that it's Monday, November 11th. And remember that there's a time here as well that we could express. And so if we go here into the more number formats, then it could have tell you what time of day that is, 11:19 a.m. So it's kind of an interesting way that it's viewing time there. There are functions to do conversions between time so that you don't have to manually add things together yourself. Excel can do all the heavy lifting for you. And you can, just as I've demonstrated, change the formatting to switch between a wide variety of options. You can have it do date, month, year, month, date, year, you know, however you like to format it. So again, the way to get at that formatting is you do the Format Cells option, and looking on that tab, and here instead of being General, you can click on the drop-down box, and then it gives you a much larger list of options besides General. So let's practice that a little bit more. So the first thing I'm asking here is the date equivalent of this number. So let's type that number in here. Okay, so 7190.471736111111. All right, so we've got some number in there. Now it didn't show all of the same decimals that I had typed in, but you can see them here, all the ones that I typed in. And if I want to show them all, then I can increase the number of decimals that are shown until they're there. Okay, but this is the number of days since January 1st, 1990. I don't want to necessarily display that as a number, so I'm going to click here to the drop-down box, change it to more number formats, and I guess I don't necessarily have to go to more number formats. I could just use the short date and see that it's September 9th, 1919, or if I wanted to have it as a long date, it'll tell me the day. But if I really want to have include the day of the week, what about 24-hour time? You know, rather than saying AM or PM, I want to have it be in the 24-hour military style. So if we scroll down here, then that's going to be the 24-hour time. And so I guess that's not very exciting because it's still in the AM. So that is how you can use Excel to keep track of time. Decimal days. Now let's play around with the VLOOKUP function. The VLOOKUP function, just to give you an idea of how it could be useful. Let's say that we have people who have earned a certain score in their course. And Mr. Bean has a score of 46. Well, according to the standard grading system that is usually used, that would be an F. So we could manually type in F. A 61 would be in the D range, so we could manually type in D. If it's a short list, just a handful of students, then it's not so bad typing those grades in manually one by one according to the grading table. But it can get kind of a hassle if it's a long list. You know, when you've got 40 or 60 students or maybe hundreds of values that you need to assign some sort of a scale according to an input value, then the VLOOKUP gives you a way of automating that rather than manually having to type it in. So here's how the VLOOKUP function works. It's going to be an input value, a data range that that you're looking in, and then the column number using the row value for the input. So for example, we're going to take this grading scale. Let's do this, create a new VLOOKUP tab. Okay, so here is VLOOKUP tab that we're going to be doing the exercise. And let's copy over that same data that we've been working with so far. Okay, so here is the student score. We are going to have a grade, but we're not going to manually type that in. We want it to actually accomplish it with the VLOOKUP. According to the grading table, now let me do it here, grading table, here's the score and the grade. Okay, so if someone has a 0, they get an F, and the F continues through 60. But once they get to 60, that's the threshold for beginning a D. Now it's important that we do this in order of smallest to largest. All right, so once it gets to the 70, then it begins to be a C. Once it gets to 80, it begins to be a B. 90 is when it begins to be an A. All right, and if we had it in the reverse order, things wouldn't work. So it's important that we do it low to high. All right, so let's put in the names here. Mr. Bean, Rowan Atkinson, Monty Python, Chico Marx, Harpo Marx, and Groucho Marx. All right, so those are our students, and now their scores are 46, 61, 81, 97, 92, and 83. Okay, so since this is our first time using it, we can click here on the function just because it gives us some nice prompts. And so I can type in VLOOKUP and search for that function. Here it is, the one we're going to use. And it gives us some nice prompts here. For example, the lookup value that we want to use is the score. And now here for table array, we need to say where is the scoring table. So that's going to include both columns and all of the rows that the scoring table is in here. So I'm going to click on this and select the entire range of the scoring table. Now this last part, it's asking, it says which value should it like report. And so it's asking, you know, what column number is the grade data in. So it's in the second column. We have a 2-column array. Here's column 1 of the array, which is the numbers, and column 2 is the letter grades. So by telling it column 2, then it's going to report the grade that corresponds to the score that's coming in. Okay, so if I click OK now, it's automatically assigned the F. And here's the function that it did that. Input according to the table, and then the output goes here in C5. Now the tricky thing is if I want to repeat that over and over again, I need to anchor the values of the grading table with the dollar signs. Otherwise, when I drag down, then that grading table reference is going to look lower and lower for each row. So I'm going to put in the dollar signs by just pressing the F4 button, and it will insert those dollar signs. So there's the now it's changed the function, and so now I can drag that down, and all of the grades are automatically assigned. You can see the 83, it automatically goes and finds the B, the 72, it automatically finds the C, and so on. And all of those are correct. So VLOOKUP, very useful. Okay, now what about if and then? If is a conditional or a logic statement, and the way that you'd use it is, you can see that it's doing some math here. We're calculating how many square feet per outlet there are in a certain room. And so first of all, we've got the length of the room in feet, the width of the room in feet, and so from that we're calculating the area, and we know in the room how many outlets there are, and so it's calculating the number of square feet per outlet. But in one of the rooms, in fact 2 of the rooms, there's no outlets. And so if you do that something divided by 0, then Excel gets kind of freaking out because it's saying, well, you're trying to divide by 0, exclamation point. So we don't want Excel to feel nervous about that. So one way that we could use an if-then statement is to say, if the electric outlets is greater than 0, then do the calculation. But if you don't have any outlets, then the other side of that is we could just say that there's, we could just say like not applicable or something like that. So let's try that out. Let's use the if-then statements. And the format of an if-then statement is, first of all, you have to use equals if, and then inside the parentheses here is the test. So a test can either be a greater than or less than. It can be an equal to. Those are the main ones. And then in the second field is you tell it what to do if the test is true. And in our case, if it's true, we're going to have it do that mathematical operation, which is the area divided by the number of outlets. But then if it's false, if the test is false, then we'll have it either return a string or some other number. So let's give that a try. I'm going to create another tab here on my example file. I'll save that. Okay, so this one is going to be my if-then tab. And I'm going to copy in that same data that we had before. So here is my electrical outlet analysis. Okay, so there's a room number, the length in feet, there's the width in feet, the area in square feet, the electric outlets, and then the square feet per outlet. I'm going to change the width of some of these. Oh, this is pretty wide, so I'm going to do wrap text. That's nice. All right. So room 1 through 5. And the room was 24, 24, 12, 36, 36. Just typing in the same value that you can see on the screen there with 36, 24, 12, 52, and 52. Okay, so the area is calculated as the length times the width. I can drag that down. And now the number of electric outlets, that's just keyed in. Maybe we went into each room and counted the number of outlets. Alright, so now this is where we're going to use the if statement. Ordinarily, if we didn't have this 0 to worry about, we could just say square feet per outlet. And that works good as long as we don't have dividing by 0. We don't want to do that. So here's what we can do. Equals if. Now it's saying, first of all, the logical test. Let's make it so that if the electrical outlets is greater than 0, then we'll have it do the calculation. So then do the area divided by the number of electrical outlets. So it'll do that calculation if it's true, if there's more than 0 outlets. Otherwise, so comma, now tells it what to do if it's not true. So if the outlets isn't greater than 0, then maybe I'll just have it return a string. So I'm going to put in like not applicable as a string. Alright, so it does the calculation for the first one, for the second one, the third. Now here's the real test, is what it does there. Not applicable. So it returned that text that I had put in there, and it tells me that there's no square feet per outlet because there's no outlets there. I could change it from a string. I could just put in 0, and then it would do the test and just return a 0. But 0 is not true because it's not 0 square feet per outlet. But I think you probably get the point that the if-then is all dependent on the test. If the outlets was greater than 0, that was the logical test, then what goes into the second field here is the calculation that you want it to do if the test is true. And then if the test is false, then you have that third field. If then, it's a very useful thing. Alright, so that is it for this lecture. What I need you to do is save this file and go to MU Online and upload it to the class the class that's indicated for February 28th. And so you'll upload to the 2/28 area in MU Online. And that's how I will assign the attendance credit for today's lecture. So thank you. Please let me know if you have any questions. And just as one final reminder of the announcements, let's look at this slide that tells us homework 5 is due before 11 o'clock on Tuesday, March 7th.